I want to thank you, all of you, organizers and the participants, because of you, we can make these great events that we all learn from each other. So thank you, and I hope this talk will move some inner strings in you. I'm going to talk about the variability above and below ground of carbon stocks in an ecological park in Querétaro, La Joya-La Barreta. As you can see, there are many people involved, and this is just a tiny branch of a bigger project that we're creating with different labs and different people, different investigation lines. We'll talk about this at the end. So, okay. As we know, soil organic carbon is essential for soil health, for fertility, productivity, soil structure, water retention, microbial activity, and nutrient availability. Mostly for plants, but it also for bacteria, fungi, and many other organisms from macro and microscopic. So, soil organic carbon, therefore, it also contributes to food security and climate change mitigation. La Joya-La Barreta Ecological Park, it's of great ecological importance as it hosts many native flora species. It also is the habitat of many fauna species, some of them in danger, some rare snakes, but also, and mostly, it's a key ecosystem for carbon sequestration and storage. So, our aim to this study is to measure and estimate the carbon stocks, first using the SOC, soil organic carbon, the VOC, vegetation organic carbon, and also the basal respiration as an indicator of microbial activity. This study provides an essential baseline for sustainable management of the park and decision making in the context of greenhouse gas mitigation. Okay, well, La Joya-La Barreta Park is situated in Querétaro, Mexico. It has 245 hectares of extension. It's a semi-dry weather. Precipitation ranges from 47 to 111 millimeters. And temperature is from 13 to 27 Celsius. Here we can see the three principal vegetation types of the park. In pink is shrubland, yellow grassland, and the green one is oak forest. We measure carbon stocks, the VOC, SOC, and basal respiration from 2 consecutive years, from 2023 and 2024. Okay, we established 116 transects of 10 by 10 meters each. At each transect, we took soil samples. One in the center from bulk density with the help of a cylinder that we know the exact volume, and another from the first 30 centimeters from the mineral soil layer. We also made a basal area where we measure all vegetation in each transect that we have the diameter breast height, the height, and the cover. And for basal respiration, we measure the soil dry samples, we saturate with water, and we capture the CO2 parts per million a long time. Here we are, the ABCs, soil samples, bulk density, and measure the vegetation. So, we took these soil samples to the lab so we can analyze the carbon concentration using the methodology by the Mexican official standard. that is basically the wet combustion method. We analyze the bulk density, calculate the bulk density with these cylinders. That is the dry weight by the volume. The VOC was calculated by allometric equations, and the C stock, the carbon stock from each individual, was obtained by multiplying the biomass by the expected carbon fraction. Then we got the field data, the lab data, but we wanted more, no? We always want more biolog, more information, so we can make more precise and better analysis. So we downloaded the Landsat 8 spectral images with 4 meters of resolution. With those, we calculated topographic features like slope, elevation, curvature, total catchment area, and so far and so on, so many. After that, we calculate the NDVI, the Normalized Difference Vegetation Index, and then we use this index to compare the soil data between years, the 2 consecutive years. Then we get a little bit nerdy, and we use, with the help of machine learning and AI, we try to predict and model these carbon stocks in the park. So we use random forest algorithm enhanced by the simulated and feature selection. We use external validation to train the model, and we then get to the results. So here again is the extension of the park. Here is the shrubland, grassland, and the oak forest. For carbon stocks, we compare only the shrubland and the oak forest. For basal respiration, we analyze 3 vegetation types. So here, it doesn't look, maybe you can look, but the dots are the first year's samples, and the triangles are the second year's measurements, no? The sample. Okay, when we estimated the VOC in oak and shrubland, we see a low correlation. It's not bad, but it's not good. it's 0.39. That means that 39% of the variation of our data from one year to another, we can explain it with the first years. So this, we saw we get an increase of the VOC in oak forest here from the second year, but a decrease in the VOC in shrubland. What does it tell you? What does us tell you that? Tell us that, sorry. Many things. So, for one, is that carbon stocks above ground are more dynamic. They change within years. That's some way fast, and that shrubland it's more sensitive or vulnerable to climate changes like temperature, the dry season, the rainy season, etc. And if we take this information out of an ecological park that is protected, we can introduce the anthropogenic disturbance. Okay, so we got somehow 39% of the variability explained with the first year, with the VOC. It varied from 8.6 to 15.5 tons carbon per hectare across years. So when we model, when we use the NDVI, we see that the oak forest has an increase, mainly in the upper part of the park, which is like the more pristine, quote, quote, of the park. And with this prediction, we understand that it's not only a shrubland cover loss, but it has some loss in where the water availability is less, but a little bit positive effect in some places that obviously the shrubland can get more water within years. So when we compare this modeling, we can see that the extreme colors, red and blue, are where the model doesn't fit very well, that we have to be cautious about the interpretation, but the white colors are within, it's more fitted. You can be more secure that your information, all those numbers are there in reality and not just a number that the algorithm gives you. Okay. And obviously here in green the oak forest and in purple the shrubland. Okay, let's pass to the SOC. Here, first we have that our mean was pretty similar across years. The second year, the 2024, was less dispersed in comparison of the first year. And when we see the correlation, now we got a better correlation. That is 75% of the variability can be explained with the first sample year. And what does it tell you that? Well, that underground carbon stocks are more stable within years. And this is somehow expected because it's more stable in the soil. It's a protected area, so it's less disturbed by anthropogenic activities. And we hypothesize that we can change carbon stocks below ground can be changed in greater time lapse, not across years. But then again, this is not the end, and we're gonna sample another year, and we can make another included in this analysis and see if we find a pattern, or let's see. So we got a moderate correlation, and the SOC variation across years was around 130 and 140 tons carbon per hectare. So then again, it's below ground is more stable than the VOC. When we model, there we have the 2023, and the difference. So here we see that both maps are pretty much the same. Here we see the increase of SOC, and when we test the Wilcoxon test, we show that there are no significant difference. So effectively, we can see it in the difference map in C, that is almost white. That means that the model was better, but was robust, with a little extremes here. But again, we can explain 93% of the variation with the first sample here. So this again shows that below ground carbon is more stable than VOC, and we can predict very well, at least in SOC, with these sample years. And if we talk about shrubland in SOC, the first analysis tells us that it was a decrease, but when we predict and model, we see that we have both. We have a positive effect in lower parts of the park, but a negative effect across years in the others. We think that is because water availability, and that's the temperature change when it's very dry, and shrubland is more propense to change or to die and wither across years because of that, than oak forests that are more resilient, they are bigger vegetation, so they're more resilient. Okay, basal respiration as an indicator of macrobial activity. This graphic shows the CO2 parts per million over time, and the three kinds of vegetation. As we can see, oak forests has more microbial activity, more than 5,000 parts per million, in contrast to grassland, that is like half of it. Shrubland looks more like grassland, but oak forest is essential in this kind of vegetation, in this zone, in these two sample years. Okay, well, our results suggest that VOC are more variable above ground, obviously. If we predicted for all the park area, we varied this range from 2,107 and 3,007 tons of porcaron in all the area of the park. In contrast, SOC are lighter stocks and they're more stable, and they vary from almost 32,000 to 34,000 tons per year. Also, respiration is higher in oak forest. So these results allow us to develop digital taro mapping frameworks to refine estimates on each corner of the park, and eventually to other areas or interest or with other organisms. These kind of tools can allow us to analyze and predict from medical, geological, biological. The sky is the limit. So just to end this, we are creating a larger group of investigators, researchers, different research lines to make information available freely in digital repositories or legal, to understand better how our results are from different points of view, different researcher lines. So it's imperative that we can get together and contribute with all your expertise to make better data for all of us. That's the only way we can make sustainable management plans better, and we can change and protect our soils from everything. So, thank you.
Thank you very much, Mariano, for the presentation. And there's time for questions. Well, there's a comment.
Congratulations, Mariano. Very nice presentation. I think two things. I think it's important to give the QuerÄ information for the database, to invite everybody. So if you can put your email, or if somebody is interested, or us to contact you to participate on this database that is so important. And the question is, I saw that you improve very much the confidence of the model in only two sampling periods. Maybe too much, 30% is too much. So how it works? Because normally it should be, do you have already identified the factors of uncertainty in the model?
Okay, yes. Again, SOC is more stable, and we have 116 soil samples. So it was very good to see that how it fits. But we also, this kind of algorithms, you just don't look to the determinant coefficients. They have another measurements, like the RMSE, the root mean square error. So you can, gives you the values of the predictor and the real data. So you can see how much in reality that can be, because you can get a high correlation or prediction value. But in reality, it's not that. But we have several measurements that they can show us, this is pretty effective, or be cautious about that. No, it has a lot of variation, a lot of error. But in this case, it was very fit. And yes, well, our working team, it's mainly from Geoscience Institute of UNAM, Uriquilla, but we want to invite you all in and out from UNAM, in and out from Mexico. It's our responsibility and somehow to make all the information that you have, that it's essential, to be shared by everyone so we can make better and be wiser about soils.
Here I have a question. There is a field quite far from mine, so that's why I want to ask these kind of things. It's quite my understanding that carbon sequestration is done by some way measure from vegetation layers or something like that. My question, and it's my understanding that carbon sequestration is a good measurement for to dedicate a place or for to select a place as a restoration or something like that, not like a measurement. In such a way, I'm thinking in Cuatro Ciénegas, there is a way for to measure, there is not so much vegetation. So there is a way to measure carbon sequestration in these fields where you have the mats, for instance, that there are biological layers of bacteria, and how this can be differentiated with the carbon that can be sequestrated in other ways. Thanks so much.
Okay,